Alright everyone, today our topic is VR visualization to enhance the effectiveness of congestion. These are table of content cover background to suggestion. Okay, I'm going to discuss the background for VR-based BIM visualization. Usually, two-dimensional drawings and screen-based 3D models cannot fully convey, often lead to design error, costly revision, and misconnection. So VR-based BIM visualization provides a solution by immersing stakeholders in one-to-one skills digital prototype of project. The benefit is that design errors and safety hazards may be reduced by 50%. Furthermore, the early identification of issues can lead to significant cost saving, with saving over $100,000 per project. VR can also enhance the collaboration without oral discussion. The detail will be discussed in benefit. For clients, especially on high-end projects, this immersive experience boosts their engagement and lead to more informed decisions. About the method and device, we choose the HTC5 and those are two photos showing the function of real visual view based on the camera sensor with the controller, also the USB Type-C linking with the computer and the VR to translate our movements into virtual environment. Regarding the step, first we need to confirm the setting. Second, for the software like Escape, the digital models is translated into immersive world. This photo is a 3D model.
In this part, I'm going to talk about the experience using BIM VR. In our first trial conducted in mid-October. Fourthly, I'm going to talk about the potential application areas. In the application areas, we can divide into following. Challenges remain, such as steel requirements. Next part, I'm going to talk about the potential application area. In our second trial, we tested feasibility by asking, can BIM
Next, I will talk about the benefit and the challenges of using the VRO. By integrating the VRO with the BIM, it enhances the collaboration. It offers an interactive platform where the team can work together more effectively. It reduces the miscommunications and the misunderstanding, which are common challenges in the traditional workflow. The teams can provide immediate response to the conflicts and the decision, improving the project efficiency. The ability to visualize the design together fosters the better teamwork. Moreover, it can reduce the cost and have the time saving of the project. The material waste and the labor cost can be reduced. This is achieved through the accurate visualization that accelerates the approval process and prevent the costly error. For example, the team can schedule the construction activity more effectively, avoiding the task overlap for faster project timeline. Another crucial advantage is the error detection and the risk integration. BIMVR allows the team to explore a real-scale model of the building design. This helps identify the crash and the conflicts such as HVAC, plumbing, and or the ceiling early in the process. It can also identify some safety hazards such as level pathway and inappropriate access point. This can be detected and extracted. By identifying this issue earlier, we can minimize the risk, avoid the project delay, and create safety work environment. There are some challenges need to be considered. Firstly, the technical limitation and the hardware requirement. Running large BIM model demand high performing hardware and software. Lack and visual limitation can reduce the workflow efficiency, and the lack of tactile feedback can lower the immersion and make the disconnection. Next, the training and adoption pose the challenges since the BIM VR system is a relatively new method. Many professionals may lack of familiarity with the technology, resistance to train, and the high costs associated with the training can slow down the adoption. However, with the proper training, this barrier can be overcome. Finally, the user discomfort is another challenge. Extended use of VRO can cause a disconnect with the body's physical sensations. Users may feel dizzy and fatigued when they spend extended time in reviewing and analyzing. This may cause the VRO sickness. This phenomenon is appear often due to the imbalance of the vision motion of the user. Technical issues such as input lag and low frame rate or the prolonged use of the headset. Therefore, it is essential to limit the VR exposure time.
As we discuss limitations, I will provide some suggestions. Let's simplify the interface. Instead of joystick, we can use more natural body movement for navigation, such as lead to move forward, rotate shoulder to turn. It's only 2 degrees of freedom, making it accessible for beginners. Second, adjust the ergonomic hardware must feature adjustment for interplanetary distance and improve the movement simulation, unlike visual motion with real sensory inputs to integrate physical discomfort. And third, optimize the performance by reducing program counts and occlusion cutting on non-necessary details. We can improve the rendering speed and estimate leak, making the experience smooth and comfortable. The photos show that an object has 12 faces, each with around 102,000 polygons. However, it has over 201,000 faces with masses around 2,901,000 polygons. It shows that a good performance of real does not depend on total number of objects, but on the capacity. This is our reference. This is our presentation. Thank you.